Hello everyone. In today's class, we will go for discussing structural testing. The contents for this class is we will first go for introduction, what is structural testing. We will briefly see what is white box testing, and we will go for discussing some structural testing techniques. So structural testing is considered more technical than functional testing. So it attempts to design test cases from the source code and not from the specifications. The source code becomes the best document which is examined thoroughly in order to understand the internal structure and other implementation details. So structural testing techniques are also known as white box testing techniques due to consideration of internal structure and other implementation details of the program. So as compared to functional testing, the test cases we go for generating that was depending upon the SRS document. So the SRS document is the best document depending upon which in functional testing we go for creating test cases. As compared to this, in structural testing, the source code becomes the best document which is examined thoroughly in order to find out what is the internal structure and how the code has been implemented. So that can be studied thoroughly. So we will see what is white box testing. So here the software you can think of as a white box, or it is a glass box or an open box. That means what is happening inside that we are interested for. So here we give certain input to the system, and then we are going to see inside the software or how internally the code works after getting some input from the outside world. So this is the way. So that is the reason why the structural testing is called a white box testing, right? So white box testing, it helps us to go for, or it is going to help the software engineer to create test cases that guarantee that all independent paths within a module have been exercised at least once, exercise all logical decisions on the true and false sides, execute all loops at their boundaries and within their operational bounds, and it exercises the internal data structures to ensure their validity. These are some of the white box testing techniques, or we can say the structural testing techniques also we can say. They are statement coverage, branch coverage, condition coverage, and path coverage. So one after another we will go for looking each and every technique separately. So first we will go for what is statement coverage. So if we define statement coverage, the definition can say in this way: choose a test set T such that by executing program P for each test case in T, each basic statement of P is executed at least once. So whatever the test set that you are going to prepare, so what is a test set? It contains some test cases or a set of test cases, right? So we have to choose the test cases in such a way that each and every statement of my program that should execute at least once. If this is happening, then I can say I achieved statement coverage, right? So we'll go for one example here. Suppose this is a program that we are interested to test. If you look at the program, it is simple a C program. So we are going to enter three numbers, and that is going to be stored in the variables A, B, C. And I am putting a condition here: if A is greater than B and A is greater than C, then I will come inside the true part, and I am going to execute the line X equals to A multiplied by A plus B multiplied by B. And then again I am going to check the condition: if B is greater than C, then I am going to compute the value of Y. Again it is a into a minus b multiplied by b, and finally I'm going to print the values of x and y. So this is a simple program. So if you'll go for constructing the control flow graph for this program, the graph may look like this, right? So each and every statement you can represent in a node. So if you look at here, 1 minute. So if you look at here, line number 1, 2, 3, 4, 5, 6. So sequentially, the flow is like this, execution of line 1 after another. And if you look at line number 7, here basically a condition is there. So the branching operation is performing here. So here in 7th node, right? Node number 7. So if you look at here, there is a true path and there is a false path, right? So if the condition is true, I am coming inside and line number 8 gets executed, and then line number 9, and then I'm going for the line number 10. But if the condition fails here, I'm not supposed to enter into this true part, and directly I'm going for line number 10. So that is happening here. If this is false, I'm moving in this way. Again, in line number 10, it is a condition. So again, branching is possible. So 1, if the condition is true, you are moving through line number 11, 12, then 13, then 14 and 15. And if this fails, then straight away you go to the line number 13 and then 14 and 15. This is the end of the program, right? Now for this program, if somebody is going to select a test case like this, a equals to 9, b equals to 8 and c equals to 7. Now question is, by selecting this test case, whether we are achieving statement coverage or not. That is the question here. So if you are going to take these three values, a equals to 9, b equals to 8 and c equals to 7, and simply you traverse through this control flow graph, right? So 1, 2, 3, 4, 5, 6, that goes sequentially, no issues there. Come to line number 7. So a equals to 9, b equals to 8 and c equals to 7. So yes, a is greater than b, condition true, and a is greater than c, yes, condition true. So after executing this line, I am moving towards this. So line number 8 gets executed, then line number 9, then come to line number 10. So again 10, b is greater than c, yes, b is 8, c is 7. So yes, this is true. So I am moving in this direction, in the true direction. So line number 11, line number 12, then line number 13, then line number 14, and then line number 15 gets executed. That means with this test case, I am able to execute all the lines of my program starting from 1 to 15. I am not going to miss a single statement in my program. Getting? So now we can say, with this input value a equals to 9, b equals to 8 or c equals to 7, then we are able to achieve statement coverage with the help of only a single test case, right? Similarly, the next technique is branch coverage. So what is branch coverage? The definition is like this. So choose a test set T such that by executing program P, for each test case in T, each branch of P is executed at least once. That means you are going to choose a test set in such a way that if I am going to execute my program with the help of these test cases, then whatever the branches of my program is there, all the branches, they should execute at least once. It should not miss a single branch in my program. If this is happening, then I can say I achieve branch coverage. So now we are going to take the same program again, draw the control flow graph. The control flow graph will look like this. Now if I'm saying, if I'm going to choose a test case like a equals to 9, b equals to 8 and c equals to 7. So question is, we are achieving statement coverage. Already you have seen this, and whether you are achieving branch coverage or not, or in other words you can say whether statement coverage and branch coverage both are achieving or not with the help of this test case. So already in the previous slide, already you have seen with this input value a equals to 9, b equals to 8 and c equals to 7, we are able to achieve statement coverage. Okay, but question is, what about the branch coverage? Whether with the help of this test case we are able to traverse all the branches of my program or not. So if you look at all the statements are executed, we achieve 100% statement coverage, but branch coverage is not there. How? You see, if I'm going to traverse through this graph, at this point, at this node where I'm going to put the condition, I'm moving in this way, that is the true path I am following or the true branch I am following. Again at the line number 10 I am executing another condition, so I am moving again the true path here. But what about the false side? I am not able to traverse through this branch. So that's the reason why with this value a equals to 9, b equals to 8 and c equals to 7, though I am able to achieve statement coverage, but I am not able to achieve path coverage. Then what I have to do? I have to go for adding a new test case like a equals to 7, b equals to 8 and c equals to 9. So with these two test cases, so you see this is for the true path, already you have seen, and with this value, so a is greater than b, now it fails, so I am moving toward the false side. And similarly b is greater than c, no, again the condition fails, I am moving toward the false side. So once I am going to update my test case with this value, I am going to add this value as two different test cases, then I can say I am able to achieve 100% branch coverage also, right? Next one is condition coverage. So the condition coverage states that choose a test set T such that by executing program P for each test case in T, each condition of P is executed at least once. So in the branch coverage we are talking about the true side and the false side, but the condition coverage says whatever the conditions are there in a program, all the conditions should be tested at least once. If this is happening, then we are saying we are achieving condition coverage. So branch coverage can be achieved without testing every condition. So the condition coverage, to achieve condition coverage, your test case may be more sophisticated, because in some cases you will see that you may achieve branch coverage, but there may not be the condition coverage. It may happen, right? So we are going for the same example here. So the control flow graph, already we have discussed how to draw this graph. So if you look at this condition here in line number 7, a is greater than b and a is greater than c, so there are two conditions are there. So there will be 4 possibilities here. The first possibility may be both may be true, a is greater than b, a is greater than c. Second possibility is first is true, second is false. The third possibility, first is false and second is true. And the fourth possibility is both are false, right? So we have to choose the test cases in such a way that whatever the conditions are there, how many conditions are there? 2 conditions, a is greater than b and a is greater than c, right? So both the conditions we have to go for testing. Accordingly you have to choose the test cases. So if you look at here, if I'm going to choose a test case like a equals to 9, b equals to 8 and c equals to 7. So first possibility, when both are true, yes, a is greater than b and b is greater than a is greater than c. Now if I'm going to choose like this, a is equals to 9, b equals to 8 and c equals to 10. So the second possibility here comes, because the first condition is true, yes, a is greater than b, and the second one is false, that is a is greater than c, it is false. And third and fourth possibilities, you see, a is greater than b, so a value a equals to 7 and b equals to 8 and c equals to 9. This is another test case, right? So once the first condition fails, as it is the AND operation, so the entire operation becomes a false operation, or the entire condition becomes a false condition. And if both are false, right, then also the statement number 9 is going to give you a false result. So that again we are achieving. So with these three test cases, here we achieve condition coverage and path coverage. So the definition says like this: select a test set T such that by executing program P for each test case D in T, all paths leading from the initial to the final node of P's control flow graph are traversed. So in the control flow graph, you go for traversing from the initial node to the final node. So whatever the possible ways are there, that is called basically a path. So the path coverage ensures that you have to go for selecting the test cases in such a way that all the paths in the control flow graph which starts from the initial node and ends at the final node, they should be traversed at least once. If this is happening, then we say we achieve path coverage, right? So look at this program here. Are they positive? So this is a function which is going to take two input values like x and y, and my function is going to check whether the input values are positive or not. So what I'm trying to do, I'm going to test x is greater than equals to 0. If yes, then I'm printing x is positive, otherwise x is negative. And then I'm going to check the y value. If it is greater than equals to 0, then I'm going to print y is positive, otherwise I'm going to print y is negative, right? So if you draw the control flow graph for this program, it will look like this. So you see, this is the first node. I'm going to check x is greater than equals to 0. If it is true, I am printing x is positive. If it is false, I'm going to print x is negative. Then what I'm trying to do, I'm going for checking another condition, that is y is greater than equals to 0. If it is true, I'm going to execute y is positive, otherwise I'm going to print y is negative, and finally my program ends here. So if you look at from the starting node to the end node, so this is my initial node and this is my final node where my program ends, right? So if you look at here, you can move in this way, in this way, in this way, in this way. This may be one path. You can move in this way, in this way, in this way, and in this way. This is another path. Here, here, then go this way and go this way. This is the third path. Or you can move in this way, B0, B2, then B3, then B4, and then B6. So there are total 4 different possibilities are there, or 4 different paths are there from the initial node to the final node, right? So if I'm going to test this program with the test case like this, x equals to 12 and y equals to -5, and x equals to -1, then y equals to 35. If you go through this control flow graph, then it gives you both branch and statement coverage, but whether you are achieving path coverage or not. Now you check it out. So x equals to 12 and y equals to -5. So you see, x is greater than 0. Yes, true. Come this way. Print x is positive. Then come here. Check the y value. It is false. Come this way. Print y is negative and return. So you are following the path B0, B1, B3, B5 and B6. Right? Now take x equals to -1 and y equals to 35. So check the condition here. It fails. Come here. Print x is negative. Come here. Check the y value. It is positive. Yes. Y is B. Then B6. So out of all these 4 paths, only you are able to cover 2 paths like B0, B1, B3, B5, B6, one path. B0, B2, B3, B4 and B6. Rest 2 paths we are not able to cover with these two test cases. Then what we have to do? We have to go for, so look at here. So test set T2 execute only these two paths. So though we are having 4 different paths are there from B0 to B6. B0 initial node and B6 is the final node, right? So I have to go for adding two new test cases here, right? One is x equals to 115 and y equals to -13. Sorry, x equals to 12, y equals to 5. And x equals to -91 and y equals to -2. So after adding, if I'm going to execute my program or I'm going to traverse through this graph, then I'm going to achieve branch coverage, statement coverage, as well as the path coverage. Thank you.